So far, we've discussed OSHA PSM rule, which is a regulatory compliance framework. OSHA's PSM standards lays out 14 key elements that covered facility must implement. Elements like process hazard analysis, operating procedures, mechanical integrity, training, management of change, emergency planning, and other. It's essentially a minimum safety management recipe required by law. Many companies worldwide follow OSHA PSM even when not legally required because it's recognized as good practice. But it's not the only game in town. There is also a broader voluntary framework developed by industry experts, the CCPS Risk-Based Process Safety Model. CCPS, the Center for Chemical Process Safety, is a professional organization under AICHE, American Institute of Chemical Engineers, that publish best practice guidelines. In 2005, CCPS introduced the Risk-Based Process Safety RBPS approach, which expanded on OSHA's PSM. The CCPS model has 20 elements grouped into 4 pillars: commit to process safety, understand hazards and risk, manage risk, and learn from experience. These 20 elements include everything in OSHA's 14 and then some. Notably, CCPS explicitly includes management concepts like process safety cultures, compliance with the standards, and continuous improvement, which go beyond OSHA's requirements. In other words, OSHA's PSM is about complying with the specific rules. It gives you the minimum, whereas CCPS approach is about striving for excellence in safety. CCPS risk-based PSM encourage companies to proactively improve and tailor their safety system based on risk. It's not mandated by law, but many leading companies adopt it to achieve a higher level of safety performance. To compare briefly, OSHA PSM 14 elements is mandatory for those who meet the triggers. It's somewhat prescriptive. Example given, you must do hazard analysis, must have certain procedures and other. And it sets the baseline. CCPS RBPS 20 elements is voluntary and more extensive. For example, process safety culture is one of CCPS elements that mean fostering an organizational culture where safety is a core value, something not explicitly required by OSHA, but obviously beneficial. CCPS also emphasizes things like using metrics and audit for continuous improvement. The key point is that both models share the same goal, preventing accident, but the CCPS model goes beyond compliance, pushing for best practices and continuous improvement in safety management. Many companies use OSHA's framework as a foundation and then layer the CCPS concepts on top to strengthen their programs. For our audience of safety professionals and engineers, it's good to recognize both. Meeting OSHA PSM keeps you legal and safe, but embracing a CCPS risk-based approach can elevate your safety program to the next level. Ensuring things like strong safety leadership and engaged workforce and ongoing improvement are in place. Both approaches ultimately reinforce The idea that process safety needs a systematic approach. You can't rely on one gadget or one checklist. It requires a holistic management system. Let's dig a bit into how PSM actually prevents accidents. A core principle of PSM and process safety in general is the use of multiple layers of defense, often called layer of protection. No single safeguard is 100% foolproof, so we build several safeguards so that if one fails, the next one can save the day. You can picture the Swiss cheese model. Imagine a slice of Swiss cheese. Each slice is a safety layer like a device, procedure, or control. Each slice has some holes because of no safety measure is perfect. But if you stack enough slice, the probability of hazard finding a path through all the hole becomes very low. In practice, this means PSM employs technical controls, administrative controls, and emergency measures working in unison. What are some of these layers? At the base, we try inherently a safer design, choosing less hazardous materials or less severe conditions when possible. It means the first priority is to eliminate or minimize the danger at the source. Then we have engineering controls, for example, automatic shutdown system, pressure relief valve, ventilation system, gas detectors, and alarms. Next, we add operational and administrative controls. Things like detailed operating procedures, training program for operator, permit to work system, regular inspection, and maintenance schedule that is the mechanical integrity program. We also include management controls such as management of change reviews before modifying any process and periodic safety audit to catch problems. And as the final layer, we prepare emergency response plans so that if an incident does occur, we can mitigate the consequences. Firefighting system, evacuation plan, community alerting, and other. PSM ties all these layers together under a cohesive management system. For instance, one of the PSM elements is process hazard and analysis, or PHA. That's where you systematically review your plan to imagine what could go wrong and then ensure layer of protection are in place for each credible scenario. Another element is mechanical integrity, making sure critical equipment like pressure vessel or relief valves is regularly maintained so that those engineered safety layers remain effective. Let's consider an example scenario. Suppose you have a reactor that operates at high pressure. PSM would ensure the reactor is properly designed and built to handle the pressure. It means a safety margin in the design. There is a high pressure alarm and an automatic shutdown system if pressure gets too high. That is engineering control. Operators are trained to what to do if the pressure starts rising. It is a layer of procedures and training. Maintenance staff routinely test and inspect the pressure relief valve and the instrumental device. That is a mechanical integrity check. Any change in raw material or operating condition goes through a management of change review so you don't unknowingly exceed safe limits. And if an overpressure does occur, You have a real-life device and a vent or flare system to safely handle the release, plus evacuation drill for workers as needed. This is the layer of emergency preparedness. All these pieces collectively prevent a catastrophe. This layering is why PSM is effective. It never relies on a single safeguard. It is very important. Never relies on a single safeguard. Each safeguard is like one slice of the Swiss cheese. By stacking multiple layers, we cover the holes and reduce the odds of hazardous scenarios slipping through. The takeaway for the audience is that good process safety is about redundancy and depth, never assuming one barrier will be enough. This also illustrates why PSM has multiple elements. Each element addresses a different slice of safety. For example, training addresses human performance, while PHA addresses design hazard. In summary, process safety management or PSM is about preventing the big accidents in industries that handle dangerous chemicals. We learned that PSM provides a structured approach, often mandated by OSHA, whenever you have large amount of flammable or specific highly hazardous chemicals. It's critical in places like oil and gas refineries, chemical plants, and even other facility lots like water treatment or food processing that use hazardous substance. PSM combines engineering and management practices into 14 core elements that work together to keep processes under control. We also discussed how beyond the OSHA rules, industry best practices like the CCPS risk-based model add extra focus on things like safety culture and ongoing improvement. The essence of PSM is layer of protection. Multiple safeguards preventing any single point of failure, and a proactive culture that makes safety how we do things day in and day out. For the safety professional and engineers listening, implementing PSM is both compliance requirement and a smart operational strategy. It not only keeps people safe and protect the environment, but also improve reliability and business continuity. Fire and explosion are not good for productivity. For the general industry worker and the students, understand that PSM is there to protect you. It may sometimes seem like a lot of extra steps like detailed procedures or numerous safety checks, but those are the layers keeping the plant safe. If you see something that concerns you, speak up. That's PSM in action through a vigilant culture. Let's all take away that process safety is a team effort and an ongoing journey. By rigorously managing process hazard and fostering a strong safety culture, we can prevent the next catastrophe and ensure everyone goes home safe. PSM is critical and ultimately it depends on people like us to make it successful. In the next episode, we'll take a closer look at OSHA's process safety management model, the 14 elements that form the foundation of this system. I'll break down each element in simple terms, explain how they work in practice, and show why they're essential for keeping high-risk industries safe. Join me in the next episode. Thank you for your attention and stay safe.